This is Disruptors Unleashed, where we explore innovative technologies and chat with the trailblazers who are redefining industries as we know them. In our last episode, we discussed how ModSim transforms high-tech engineers by enhancing their speed, efficiency, and performance to the next level. Today, you'll hear from Morgan Zimmermann, the CEO of NetVibes, and David Ziegler, Vice President of the Aerospace and Defense Industry, who will take you deep into the heart of the aerospace and defense industry. Together, they'll unveil the secrets behind how top aerospace companies handle conflicting trends, accelerate development, and drive down costs, all through virtual twin experiences. Listen to how this data science-powered technology isn't just solving today's challenges, but reshaping the future of aerospace innovation in ways beyond imagination.
Hello, David.
Hello, Morgan.
Welcome. So, David, you're Vice President of Aerospace Industry at Dassault Systèmes. Thank you for joining us today.
My pleasure, Morgan.
Can you tell us a bit more about the key transformation drivers for your industry?
Sure. In aerospace and defense, the major trends or the major difficulties is about solving paradigms. The first question is how to manage opposing trends. In defense, for example, you need to develop faster with a growing complexity of products, while at the same time, keeping the cost of operations in defense down. In commercial aviation, you need to increase your production with respect, of course, to the post-COVID delivery and that big trend of the market pushing back, but as well, managing still a high level of quality of the product and also spending a lot of efforts on product decarbonization.
When I'm listening to you, these trends are probably shadowing a very major transformation challenge. It's not anymore about just introducing a new technology. To manage these conflicting objectives, you probably need to rethink the way the organizations are built and the way they work and the way they operate. How would you say 3D Experience Platform is a vehicle to support this transformation?
So one key aspect of solving these key challenges is, simply put, to reveal your virtual twin experience, your patrimony of engineering science, but at the same time, confront it with the real world. Leverage what we call real-world experience. For example, flight operations data, maintenance cost, non-conformance. So sometimes it's really complex. It's not necessarily about leveraging data and dumping data into a data lake. It's more complex than that. I think it's much more about information management.
Makes sense. So what you're stating is connect real world with virtual world. The vehicle to do that is virtual twin experience, which actually is providing the abstraction, the representation model that allows to interpret, all of that data. But in between, as you properly mentioned, that data is in many cases just raw data, non-conformance, sensor data, operation data. So that data needs to be elevated with ontologies and semantic so that it actually matches the virtual model. And this is what we call data science experience, by the way, at Dassault Systèmes. And I agree with you that using virtual twin experience as a vehicle to support the transformation that you just mentioned is probably quite a game changer. Can you give us examples, practical examples?
Sure. In aerospace and defense, we are lucky enough to have the major OEMs as our customers. And not only we provide solutions to them, but we enable their transformation. With Boeing, with Airbus, with Dassault Aviation, with Lockheed Martin, we are really at the heart of their transformation. One such example is with Dassault Aviation. For Dassault Aviation, we are essentially leveraging all the flight operations data from the fleet of Rafale for the French Air Force. We are gathering all of that data into a semantic lake. We are organizing that data against the virtual twin of the Rafale, and we are making sense and knowledge of all that data. And that enables, in turn, Dassault Aviation to reduce the cost of sustainment of the fleet of Rafale for the French Air Force, but as well maximize the availability of their product for the end customer.
In this spirit, when I'm listening to your example, the Rafale is an interesting example because indeed, we said that raw data needs to be elevated to knowledge and know-how. And in the case of such aircraft, raw data is sensor data. But raw data is also feedback from technicians, pilot reports, history of removals and reinstallation. So elevating the whole of that data, thanks to data science, ontology, on virtual twin experience, as you properly said, is a very interesting way to transform that raw pieces of data into actionable knowledge and know-how, which is then enabling to drive the efficiency gain that you just discussed.
And there are many more use cases than purely looking at the world of sustainment. But thinking about another customer, what we are doing is essentially leveraging real-world evidence from the factory floor, taking all the non-conformance data, not only from the OEM and its employees, but as well leveraging data coming from the supply chain in order to put all of that into the virtual final assembly line of the aircraft and enabling the OEM to deliver its product at a higher quality and leveraging, of course, all the associated supply chain.
Very interesting use case. I have one question for you. I was wondering how much your industry is concerned by cost and supply chain volatility.
Supply chain is a major problem. We are having so many disruptions in aerospace with vastly distributed ecosystems and supply chain that it's a major problem in aerospace. Anything you could do to help?
We are delivering industry process experiences in the automotive industry, which are probably highly applicable to your industry. We have worked with companies like Renault on understanding the impact of volatility of supply chain on their business. So volatility of supply chain is volatility of cost of raw material, volatility of cost of energy, shortage of components. And what we are doing is we're actually projecting these market trends onto the product to be manufactured and onto the production to be made. To do a few things. One is understand the financial impact at the product level, so you can adjust the price of the product, or the production level for budgeting purpose, and then empower with all of that knowledge procurement people so that they know how to drive the negotiation with each and every of their suppliers. Automobile are industries that have proven to have developed very strong procurement practices. From what I believe, probably a bit more stronger than in the aerospace industry. Probably leveraging these out-of-the-box industry process experiences that we have for automotive into aerospace is a shortcut to accelerated value for your customers.
I think that would be great to take all the lessons learned from the automotive industry in the procurement segment, and let's have a look on how we can leverage that for aerospace and defense.
Great. Thank you very much, David.
Thank you, Morgan.
Disruptors Unleashed is produced by Dassault Systèmes. For more episodes, follow us on Apple Podcasts, Spotify, Deezer, or your nearest audio streaming platform. To learn more about Dassault Systèmes, visit us at 3ds.com.